Hello, welcome to Math with Beth, and we are going to look at derivatives of exponential functions with base e. So first, the derivative of e to the x is e to the x. Seems very, very easy, but that's actually what makes it a little confusing because sometimes it is the exact same and sometimes it's not if there's other stuff involved. So it helps to just see a few of these done. So for the first one, because there's a number in front, don't forget that the derivative would still have that number in front, but since the derivative of e to the x is e to the x, there's our answer. For the next one, though, do you see that there are two separate functions? So we are going to need to use the product rule. So the derivative would be x squared times the derivative of e to the x, which happens to just be e to the x, plus e to the x times the derivative of x squared, which is 2x. So that would be your derivative. And then for c, I'm going to need to use the quotient rule. So the derivative would be the bottom times the derivative of the top, which is just e to the x, minus the top times the derivative of the bottom, all over the bottom squared. So x to the third squared would become x to the sixth. So just showing you how to do some of the basic derivatives with e to the x involved. Now, how about the chain rule? Sometimes you'll need the chain rule because you have a function inside a function. So instead of this just being e to the x, it's e to the 8x. So that makes it the chain rule. So how do we do the chain rule? We do the major function first. So how do you do e to the anything? Well, it's just e to the same thing. But now you have to add that step of times the derivative of that inside function. So in this case, what is the derivative of 8x? Just 8. So usually you'd probably see this written with the 8 in front at the end, just to make it look nicer. So b, same thing. You see how that's a function inside a function? So for my derivative, I'm going to do e to that function, but then times the derivative of that function that was inside. So in this case, what would be the derivative of all that? Negative 2x plus 4 plus 0 technically, so I just don't need to write that. And then c has even more going on. So first, I would probably rewrite this, e raised to this to the 1/2. So now to take the derivative, I would do e raised to that power. So we always leave that alone at first. But then times the derivative of this, I'm actually going to need the chain rule again because I have something raised to the 1/2. So I need to do 1/2 out front times this to the negative 1/2 because I need to subtract 1. But now I need to do times the derivative of that inside function, which would be 2x. So don't forget, there's no limit to how many things can be inside other things. So in this case, we basically had two chain rules going on. Finally, d, I would also rewrite. Anytime I see a square root with derivatives, I typically rewrite it as something to the 1/2 power. So now do you see this is the chain rule again because I have something inside raised to the 1/2. So I'm going to deal with the 1/2 power first by bringing it out front, leaving the inside stuff alone and subtracting 1. But now I need to multiply by the derivative of the inside, which is e to the 2x, then times 2. So again, I had another chain rule inside. Since all of this is being multiplied, you could make this a little nicer. You could definitely take the 1/2 and the 2 and see that they would wipe each other out. But I'm just trying to show you the general steps of how to do the derivatives with these. All right, what if the directions asked for the second derivative, which is what this is saying? They want the second derivative. Well, that just means start with the first derivative, but then do it again. So I got to start with the first derivative, which would be e raised to this power, but then times the derivative of that, which would be negative 10x. So I could just make that look a little nicer by bringing the 10x out front, the negative 10x. But now if I want the second derivative, I need to do the derivative of this. And hopefully you see that that is going to involve the product rule. So for my second derivative, I'll come over here because I'm going to need more room. I'm going to do the first function times the derivative of the second, which is going to involve the chain rule over here. So that's e raised to this, but then times the derivative of this plus the second function times the derivative of the first, which would just be negative 10. So there's a lot going on here. We can bring this out front to make that a positive 100x squared times this. And this I could have really put the negative 10 in front. So I didn't need that plus. And then what you'll see a lot of people do is if you have two things that both have the same e, they'll go ahead and factor that out. So again, depending on your instructor, some of them will want you to go this far. So both functions have a 10, and both functions have e to the negative 5x squared. So if I factored that out, I would have 10x squared minus 1, just to show you some of the reducing that you might run across. Okay, and then finally a word problem involving all of this. If Bob's Fish Store invested $50,000 in an account that earns 1.25% annual interest compounded continuously, you should be able to plug the numbers in yourself, but in this case they gave it to us because continuous compounding interest is P times E raised to the RT. So you should have known how to put this in here anyway, but they gave it to us. Now they just want us to find A of 5 and A prime of 5 and interpret their meaning. So A of 5 means just plug 5 into this problem. So we'll do the 50,000 times E raised to this times 5 and see what we get. We get 53,224 and 72 cents. So interpreting the meaning, this is how much money we will have after 5 years. That's what it means. Or how much Bob's Fish Store will have after 5 years. Now for the derivative, we first need the derivative. So we can't just plug in 5 if we don't even have the equation. So first, let's find the derivative of this. The 50,000 will still be there. We'll leave the e alone at first, but then we'll have to multiply by the derivative of the exponent because it's the chain rule. And so the derivative would just be that decimal. So to make this a little nicer, I can do the 50,000 times the 0.0125, which gives me 625. So this is just me making it as nice as I can before I now go to plug in 5. So plugging in 5 for t, we would get 665.31. Now, what is the meaning of that? Remember, derivatives find slopes or rate of change. So this is the rate of change after 5 years. So in 5 years, this is what's happening. We're going up at this amount per year, but that could change. So this is the actual amount of money we have in 5 years, and this is the rate it is going up at that time. So there's an example of a word problem involving the E and the derivative. So let me know if you need any more examples of that and if you have any questions. Thank you.